All right, let's do some fun ones. Just a little just for grins. Now let's look at this one. Can you factor it? Yeah. So the first thing you want to do is there a greatest common factor? If there is, pull it out. After you pull out the greatest common factor, are there any properties that I can use? Can I do grouping? Normally you do a grouping when you have 4 pieces. Can I do grouping? Can I factor it as a regular trinomial? Is it a difference of squares? Is it a perfect square trinomial? Can I use a cube of soap? Like those are the things you have to pay attention to decide if you can break these down or not. Well, before I even try to use a cube of soap or a trinomial or whatever, I see some greatest common factors with these. Let's see. This this is 2 times x, right? 2 times 4 times x, right? Ooh. Okay, so this is 2 times 4 times x. This is 2 times 4 times x. And this is 2 times x times x times x. So they all have a 2 in common, right? And they all have at least one x. Yeah, they all have one x in common. So I'm going to factor out a 2x. And when I factor out a 2x, I am left with x squared plus 4x plus 4. So far, so good? Yep. Now, this is my greatest common factor between all of them. Can this be factored? Yeah. What does that look like? Is that a perfect square trinomial? Yep, because this is your a squared. This is 2ab and this is b squared. And you're like, "Well, Dr. B, how do you see that?" Well, practice and we'll see it, but let me show you. This is x squared plus this is 2 times 2 times x, and then this is 2 squared. So that would mean that my a, if I write it out, my a is x and my b is 2. And the formula says that a perfect square trinomial, so this is a perfect square trinomial. And so I can use this, the a squared plus 2ab plus b squared is equal to a plus b squared. If you don't remember that or you don't recognize the pattern, that is okay. Can you still factor this? Absolutely. Two numbers that if I add them together, I get 4x. And if I multiply them, I get 4. Well, 2 times 2 is 4. And then is 2x plus 2x 4x? Yep. So we're good. So you got options, okay? So this is 2x times x plus 2 times x plus 2. And another way to write that would just be x plus 2 squared. Okay. Which this was the solution to this. See? So I want to move this because I don't want you to think that that's where I got that from. But this was a perfect, I'll put it right here. This was a perfect square trinomial. But if we didn't remember the property here, then you just factor like normal, okay? So factor like normal, and you'll get to the same answer. Now, why did I combine these? Because you want to make it as compact as possible. So that's why I combined them. This might be an acceptable answer. It just depends. They might say combine until you can't combine no more. And so that's why I did it that way. Now, you don't want to go back and multiply this because that takes you backwards. Remember, factoring is breaking it down into many pieces, individual pieces. Okay? Let's look at this one. And then we'll get to that one on the bottom, or the two on the bottom rather. So let's look at this one. we have x squared minus 25a squared. I can erase this now because you'll have it in the video. X squared minus 25a squared plus 8x plus 16. Factor by grouping? No, not really. Because nobody else has got an A, right? Okay. So let's move this joker over here because this is kind of messing this up a little bit, right? So I'm just going to rewrite it. Can you do that? Absolutely. Keep the signs together, and you can move this stuff around. You just got to make sure you keep the signs. Don't just move it without taking the signs with it. Now, that looks a little better. I couldn't do factor by grouping because that has no A in common, so I don't know what I'm going to pull out of here. And you could say, oh, well, that's a difference. If I do that, group that together, that's a difference of squares, right? Yep, but this isn't a difference of squares because this is 2 times 4. Now that's 4 times 4. That's a square. So let's just move it over here to the side till we get some stuff that looks like it's got some sense, right? So now look at this piece. Forget this guy for a second. Look right here. Is that factorable? Yeah, two numbers that if I add them, I get 8x, but if I multiply them, I get 16. Two numbers that if I add them, I get 8x, and if I multiply them, I get 16. Well, you're like, okay, what are the factors of 16? You got 1 and 16, you got 2 and 8, and you got 4 and 4. This gives me 8. And 4 times 4 gives me 16, right? So this is going to be 4, 4, 4x, 4x. Is there another thing that you could have noticed? You could have noticed a property, maybe. But if you don't, remember, you always have regular factoring. Always, always, always. So then let's break that down. We know that 4x plus 4x gives me 8x. And we know that 4 times 4 gives me 16. And I'm only talking about this part here. Okay, so then this factors to x plus 4 times x minus 4. And we still have this 25, I'm sorry, x plus 4 because it's plus and plus. These were both positive. X plus 4 times x plus 4 minus 25a squared. Now you're like, this don't look like nothing. Well, not yet. Can you compact this? Can you bring it together? Yeah, this is 2 of them. You see that? Same way we did up here. We compacted it. We put these together. That's x plus 4 times x plus 4. Well, that's 2 of them. Now, what do you see? Are we done? And you're like, well, you're asking us what do we see, so Dr. B, we're probably not done. This is a difference of squares, is it not? Is this a squared minus b squared? Can a be x plus 4 and b be 5a? Yeah. This is x plus 4 squared minus 5a squared. You see that? This is a difference of squares. This is where the properties come in handy. Okay? So my a is x plus 4 and my b is 5a. And difference of squares, the property says a squared minus b squared is a plus b times a minus b. So let's write it like that. A plus b, so x plus 4 plus 5a times a minus b, x plus 4 minus 5a. And that's your final answer. Properties come in handy. They really come in handy. All right. Look at these two. Factorable. Well, you're like, "Oh yeah, this is a squared, right? And this is a squared." But is it a difference of squares? Mm-mm. It's not. If you do, and here's where you when you practice these enough, you can say, "Okay, is this x plus 8 times x minus 8?" Well, that's x squared plus 8x plus minus 8x plus a minus 64. That's x squared minus 64. Does that match that? Nope. Okay, then you're like, oh, well, is this x plus 8 times x plus 8? Because there's a plus here, right? Well, let's see. FOIL it. X squared plus 8x plus 8x plus 64. That's x squared plus 16x plus 64. That's not the same. So it's not this. It's not this. Oh, maybe it's x minus 8, right? Well, let's try that. X minus 8 times x minus 8. Okay, FOIL it. X squared minus 8x minus 8x 64. X squared minus 8x minus 8x minus 16x plus 64. That's not that either. So it wasn't, none of those worked. So when you can't factor it, what do we say it is? Prime. Now, some students are quick to look at this and say, oh, that's a difference of squares. No, it's not, because that's addition. Be very careful. A difference of squares means the difference. And always check your work. Always go back. You saw how I did all three of them and I checked? Always check your work. So if that's a prime, what's this one? This one's prime too. Because yes, this is x squared. Yes, this is 6 squared. But there's no sum of squares. There's only a difference of squares. But check your FOIL real quick, and that'll let you know right away if it'll work. So this is tricky, and a lot of students get messed up on that because they're moving really fast. Don't move fast like Dr. B. I don't want you making those mistakes, okay? All right, last one. And this looks kind of woof woof, right? Let's see. You're like, how can I break? Remember, factoring is breaking it down into smaller pieces. How can I break this down? Well, let's see. What do they have in common? Both sides of this has an x minus y, right? So that might be what we need to do. X minus y and an x minus y. Let me rewrite this. So I'm going to say let I'm going to say let a be equal to x minus y. Okay? And then I'm going to rewrite it. Let a be equal to x minus y. So when I rewrite this, this is what I have. I have a, right, to the fourth minus 4 times a squared. Do you agree? If I let a be equal to x minus y, so this x minus y is a, this x minus y is a, and then I have a to the fourth minus 4a squared. Okay, so now can you do anything with this? Does this look better? So now what do we got going on? Well, what can I factor out? Can I factor out a greatest common factor? Yeah, this is a to the fourth. This is a squared. I can bring an a squared to the front, right? So let's do that. If I bring an a squared out, what am I left with inside? Well, I'm left with a squared minus 4. Y'all see that? A squared minus 4. a squared times a squared is a to the fourth, right? And then a squared times minus 4 is a minus 4a squared. All right, now what do you see? What's this? It's a difference of squares, right? This is a squared minus 2 squared, right? So this is a difference. This is a difference of squares. And the formula says a squared minus b squared is a plus b times a minus b, right? Okay, so let's write it that way. Keeping the a. So this is going to be a squared still, because that was already on the outside. We're not touching that. And then it's going to be a plus what? What's your b? So remember we said that this is a squared and this is 2 squared. So our b is 2 and our a is just the a, right? So this is going to be a plus 2 times a minus 2. If you don't see that, let me know, but I want to make sure that you see it. A plus 2 times a minus 2. Now that we've broken it down, let's come back and let's replace our a's with x minus y. Okay? Let's replace our a's with x minus y. So that becomes x minus y squared times x minus y plus 2 times x minus y minus 2. And that would be our final answer. So it helps if you can substitute when these kind of get a little funky looking. You don't have to pick A like I did. You could have picked B, or you could have picked Z. Pick something that stands out to represent what you're looking at, and then see if it starts making sense. Once we got it here, we were like, cool, I see they both have an a squared in common. So let me pull an a squared out to the front. A squared times a squared gives me a to the fourth. And then a squared times a minus 4 gives me the minus 4a squared. And then immediately we saw that this was a difference of squares. And the difference of squares formula says a squared minus b squared is a plus b times a minus b. Okay, so then a plus b, a minus b, after I determined that this was 2 squared and this was a squared, a plus b, a minus b. Now that I got this in a formula that looks kind of doable, I'm going to substitute back what I found. And that's how I had x minus y squared, x minus y plus 2, x minus y minus 2. And you stop here because we broke it down. It's broken as down as it's going broken down. This is not a difference of squares. This is x minus y times x minus y. Now, if they say this is not far enough broken down, you can say x minus y times x minus y. But remember, we want it to be as compact as possible. So you really don't want to go any further. You just want to stop here. This is fine. Cool beans?